watch this later. Yeah, so the stage is yours.
Yes, good morning to everyone, and sorry for the delay. This computer interoperability is not fully functional these days, even though all standardization and everything should be okay. But well, companies want to keep to their basis of change and so on. Today I'll talk about map making, geovisualization, and user experience for the first part of the lecture. And thank you very much for coming here, for inviting me here. Then in the second part, we'll have a short discussion. I have understood that that has been your way of doing the course. And let's get back to that in a couple of minutes. First of all, because I don't know any of you, and maybe many of you don't know me, so I need to introduce a little bit myself. Just to tell that I have been doing different kinds of things with maps for a long time, and that's probably why I'm also here then in the end. So one of the most personal contacts of mine to the cartography and maps is orienteering. That's a very common hobby in Finland, as you certainly know. So that's where I got interested into maps and using them in very low age. Then I studied, maybe a little bit due to that interest as well, cartography in the University of Helsinki in the geomatics program, where that minor and major still existed at those days. Unfortunately, since 2000s, we haven't had this this cartographic discipline in the universities, but let's see if we can work that out for the future. Most of my professional career, I have worked in the Finnish Geospatial Research Institute at the Department of Geoinformatics and Cartography, and went to a couple of places to study the cartographic topics in the world, as a researcher typically needs to do. I have worked in this cartographic association, the International Cartographic Association, ICA, which is voluntary work, but that's just for the curiosity in cartography and interest in this scientific discipline. There are these commissions which are named there. Currently, I'm chairing this Cognitive Issues and Geographic Information Visualization, or shortly put COGVIS, if you ever happen to hear about that. I made my doctoral dissertation about wayfinding with landmarks and geopictures already a little bit more than 10 years ago. I have been designing some maps for the National Land Survey of Finland with our teams, which you might have been looking at. And currently, I'm in a position of research manager, which is about applying, running projects, leading teams, and so on. Research world is very project-based, and we are a very let's say dynamic environment these days, also in the state research institutes. So it's a very varying position. I have led this group of geospatial representation and interaction in part of that shop too. And then this Finnish Cartographic Society and ProGIS ry association, these are some associations in Finland where I have been active. And this was just to say that I have some interest and already some experience also. Of course, everyone has there are many views to cartography, I must say, and that's what I also will talk today. But this is somehow my path with the cartography. Well, then for your thinking and keeping woken today, here is a task for you. So very simply, please keep awake and write down your topics of interests that we can then discuss further. I'm thinking about, in the end, a question and answer session, because I come from a little bit different environment. So, and I have been involved with this map making and the national map making. So whatever you have in mind about this, well, let's say scientific topics that I present, or then other things around this environment, then we can discuss those later for you to know more about those, if not yet aware. The actual contents of the lecture will be like this. So I will talk a little bit generally about cartography in the beginning. Then, as I come from the engineering background, and engineers, of course, like tools and also creation of tools. So we will look at those. Go for the map design, already mentioned, user interfaces, and then look at the scientific research of map use in the very end of this lecture. And based on these chapters, you can also then write down what you would be more interested to know more about. As said, I have been working with these topics some years, so I could talk more than I will now during the lecture, and that's why we can then elaborate on any of these a little bit later by the discussion. So how does this look? Can we proceed with this outlook? Okay, let's go. Maybe I change a little bit place here. So cartography first is where to begin with. And then let's go very scientifically from the definitions in the beginning. So what is a map, which is certainly like the center of cartography as an artifact? And here are some these definitions from different organizations. Maybe firstly the International Cartographic Association, which is the global kind of professional and scientific authority. We can say also scientific, because it's part of the International Scientific Association. The name is not exactly that, but it's part of the global scientific association, and as such, cartography recognized as a science of its own, so to say. And we have something from Finland by Osmo Niemelä, who has been a cartographer in also working in National Land Survey of Finland earlier, and written mainly one of the Finnish textbooks about cartography already a couple of decades ago. We have a definition from France, which is a very active country in cartography and also in this ICA. And they have a long tradition and very visual and aesthetic one, I would say. And then also from Menno Jan Kraak, from a recent book that I can go around a little bit later, and who has been a long actor in the ICA and then written a book related to the United Nations sustainability goals, and given his and their, it's a group of five people, so their definition of the map. And if you look these definitions, actually I could ask you, what do you see in each of them? Which words? Anyone want to make observation? Okay, Davi, I know. Hello.
I was just interested because the last one says often visual representation. So what would a non-visual map look like?
Yes, actually, that's a very good question because cartography as such talks about, well, representation of geography phenomena and processes as Greg says there, and then mainly visual. But yes, there are audio maps as well. And we have visual disabilities, and those people certainly are unfortunately disabled as for the maps which are mainly visual. But there have been lots of essays and there are solutions for non-visual maps as well. So auditory maps and tangible maps also. I'll a little bit touch those also later. So it's about representation of space and well, time isn't mentioned in these definitions as such, but space. So that means surrounding space around us, not the space unreachable to us in our daily life, but the space in the meaning of volume around us. And then this word representation is a central one. So meaning that we represent. So we take some presentation of the real world and then we rework it and make a new one. That's very essential for cartography. It's never the reality as the reality is, but it's always abstracted. And then this downscaled and generalized aspect in the definition of Niemelä there is very central. That also goes to this representation, but then multi-scaling, which makes us understand the space and the environment wider than only what we experience and to imagine what we have around us. I'm sure Kamir has talked about these things to you, but this is what I have followed. So hopefully not too much overlapping and maybe giving some new viewpoints anyway. Well, then of course it's always interesting to think definitions from the other side of the issue. So what would not be a map then? Is it so that everything can be a map that represents our surrounding space? And actually, very inclusively, it can be like that. But maybe if there is some image that wouldn't be a map, that could be direct remote sensing data. So meaning direct aerial and satellite images and, for example, directly measured point clouds. In the traditional cells, those maybe wouldn't be called a map because they are kind of raw collected data, and then also raw vector data would be defined as such as well. But when refining and enriching these presentations as well, like here in the case of the I think this comes from Google Maps directly. So we begin to see that the representation automatically begins to become a map because there is abstracted information and there is some text to label things and information more than the image or the raw collected data themselves. But actually, that's not very important. But if we want to try to get a little bit to the essence of cartography, well then, cartography as a science. Actually, this doesn't add very much to the definition of the map, because cartography has always been defined through the maps as a tool. So it's very, in that sense, it's very technical discipline, in fact, although very artistic as well. But it's the visual tool of a map or the audio tool of a map, if that would be the case. And we can make the same small reading exercise also here. What would your observations be about these definitions from the same authors about the cartography? you see the word maps everywhere, but what would you find out of this definition when you think of sciences? Like, does this feel a science for you, and what do you find out in these? Any comments, any ideas to this very abstract and general question as well? Well, if not too much, then well, it's in addition it being the maps, it's how the maps are made. So all the technology and the software and methods to be created to maps. That's cartography as well. Well, then I wanted to formulate from these. Now everyone could make their own definition, and I added some words to what they had done, because I always want to pinpoint that. Let's see if I get this showing. So I always want to pinpoint this purpose of maps, because every map, as it's abstracted, as it's a representation, it is purpose driven, and the purpose is a very central part of making any map. Then definition and generalization, as we have seen in the earlier presentation, and essentially some kind of pictorial representation. This goes a little bit to the semantics and philosophy of the words, of course, but pictorial we could think about being audio presentation as well. So creating a picture through audio presentation, because when we go to psychological side of the thing, we can think that actually what we have in our mind, that's a picture. So we have a media which creates a picture in our mind in some form, and that goes to the very, like, well, somehow philosophical, but also very much studied psychological side of it. I will talk a little bit more about that later. And then cartography. So it's here I myself currently I'm thinking that it's about carefully constructed maps. If we want to think, because in a way quite any representation of the reality and the environment can be a map. So when it goes a little bit further. So typically in cartography we see something that has been refined, and the artistic skills of map makers have been really in use, and they become more aesthetically pleasing and so on. So there is certain carefulness and care related to making maps and the science of cartography. Okay, then one slide about the cartographic generalization, as it is very core process of all map making. As maps always represent some intended aspects and purposefully chosen aspects of the real world, or ground truth, as that can be called as well. Then that representation is made by cartographic generalizations for every map, in fact. And we have a wide set of generalization operators to use that we find in the typical GIS software. Most importantly, and for that reason, first in this list, selection. Simply selecting which features we want to show and which not. And in the selection phase, there can be displacement made for the object to show them more visible on the available display space that is in use. Then there are geometric generalization operations for simplifying the objects, lines, for example, making lines more straight or simplified. Then merging buildings together to create agglomerations of residents, for example. And there are symbolization operators, like for resymbolizing some Now we have the building example here. So for example, giving different shapes of building types into the map. Enhancement, meaning, for example, growing a symbol to make it more visible, coloring it different. This is one topic of its own in the cartography and quite much studied because so essential to map making and getting maps communicate the actual content and the actual purpose that is sought for. All right, then about the tools of map making. In the last, well, let's say 20 years, cartography has become kind of a discipline of everyone. So mainly anyone can take tools in the internet and make maps. No education needed, in fact. And and we can easily use those maps as they have the characteristics of abstraction and representation of spatial information. Then, of course, these maps are a little bit different, and then like professional cartographers can easily criticize them for different aspects, but they exist due to big tech platforms that all have their map platforms, and actually maps have become a really central part of the businesses of these digital companies, as we observe all the way around, and where navigators, transport navigators, car navigators in the first hand, but then all kinds of navigators play certainly a very important commercial role. But also public authorities have liked very much, and other kinds of public actions have liked very much of making tools for everyone. For first of all, providing the public data into public use, as is natural by the taxation made for producing those maps, and then also collecting data. So crowdsourcing is in that direction as well. And well, in Finland we have this paikkatietoikkuna, and based on this oskari.org map platform, developed free and open source originally in the National Land Survey of Finland as well. And all countries, as you maybe already have studied, have their own map platforms. So these make maps really everyone's tools, and that's certainly very important effort, because they are not only expert tools, but meant for everyone to understand well. Well, then about the professional tools, we all in the room know GIS, of course, and there we can think about many different kinds of sets of tools which can be put under the GIS for working with the data, refining the data. We cannot do any map without data, of course. For visualizing the data, different kinds of renderings, drawings, representations, and then after that, graphically enhancing those drawn and made maps is also central. So image manipulation and layout are typically important if we want to make really well and finalized finished maps In the earlier times, Adobe Photoshop was or GIMP in open source world were central parts of making finished maps. These days, this side also has enhanced a lot in the GIS, so very well made, well drawn and aesthetically drawn maps can be made directly from the GIS. Then we need tools for distributing those maps for the view of the audience, and there we need, for example, web map tools, which are maybe the most important ones for the sharing these days, with server software, client software, and application programming interfaces. We need map software tools for producing these web map environments and other kinds of user interfaces, where programming and knowledge of operating systems is very central. So as in actually quite every technical discipline, the set of tools related for professional work is very wide, and maybe anyone can or anyone cannot know all of these tools thoroughly, but we have cartographers specialized in different tools as well, and in different parts of the cartographic production chain in different needs. I wanted to mention free and open source software still differently, because it has also really changed the production of maps during the last 20 years that I have been in the field, so to say. When I was finishing my studies, we were actually the first group who made an exercise in that time in the Helsinki University of Technology about with the free and open source software. That was just because I had went to make internship or my first summer job at the Finnish Geodetic Institute, as FGI was called those days, and there happened to be one or two persons who had studied this open source software very much those days. It was about maybe 15 years or less after the creation of Linux by Linus Torvalds and the open source movement. The open source movement is older, but I think Linux really made it fly, and then it became more and more common way of working, and these days we are in a very wide, very wide open source software world. So this also have became increasingly common then during actually these last 20 years in the GIS world, and I believe lots of your exercises and studies probably are also based on Python, open and free Python libraries, QGIS, and such tools. The closed source tools and commercial tools are also very important and core parts and central parts of the geoinformatic and cartographic software industry. But I would say that open source has made it move, because, well, commerce has kind of need to create some kind of vendor locks and try to sell their product as much as they can, which also can prevent development of the technology and solutions. So this has been very clearly seen also in the world of the GIS and cartography, as very professional maps can be made these days fully open source. Just about the modern tools, this mention about geoinformatic APIs. So you certainly know those. How many of you has sometime used some API in your coursework? I see half of the hands, so maybe not everyone yet, but these are very central tools for map making these days as well, because through APIs we can access spatial data more and more by different providers through all our main GIS programs and to get our data actually, because it makes access to the data so much easier to approach it through an API in the internet. Just basically the same idea as setting an URL in the web browser to find some web page. So then, sorry, I cannot return. Is that true? Okay, this is only forward going world. But geoinformatic APIs are the access, essentially access to the data all around the world even, and in the internet. This GeoCubes Finland, this is one example of that, made at our department by Lassi Lehto and colleagues through efforts of 20 years, which is a multi-scale API, a very technically very efficient one for searching and for querying and fetching data from nationwide. It's a system that allows searching for the map images through such open geospatial consortiums services as web map tile service, web map service, web coverage service, and such technical APIs that can then provide map images of different forms to the web browser, and so that those can be shown in our interactive web maps. Image formats like GeoTIFF, JPEG, 2000 shape, file GDP, which is actually a database format, and then also vector formats there can be fetched. And this is mainly like, let's say, advanced API, which are also elsewhere, but this was particularly developed for the needs of Finland for making access to all scales of the data faster. Well then, about map scripting, how many have done map scripting? That's also a question to ask until these days. At least one, I would believe many more as well. Yes. So that's also in the transformation of map making last, let's say this is a little bit more recent, maybe last 10 years it has become really more active. As scripting is, as well, we have been earlier we were in the world of the graphical user interfaces very much, and when we talked about GIS, and that's certainly the first touch of all of us typically to the maps and to the GIS, because it's certainly very functional and it's easy to well, not always easy if the menus are really really wide as they tend to be in the GIS, but it's typically anyway easy to conceive the software a little bit and find the functionalities and so on. And there are lots of ready-made functionalities for different kinds of tasks, like in ArcGIS and QGIS and other software. But then what becomes the complexity of or the difficulty of graphical user interfaces, GUIs, the problem is that when we make long workflows like we need in cartography to make very well-made maps, then we have long workflows, and we begin to forget what we have actually done. If we try to repeat some work that we have done and not written down, we cannot maybe do it again. And very typically in the cartographic world, also in our professional map making world, we see that we don't have enough instructions and or notes about how the maps have been made, and we cannot repeat if we want to repeat exactly, or if we want to change only a little bit. And then also the instructions of these model workflows become easily very inflexible, so they become just like direct instructions how to do something, and for repeating those, we just like follow it like a machine, and we don't necessarily or even cannot think easily how could we do it a little bit differently in some phase. And that's why this agile scripting has become so important and interesting way of working in latest years. Also because of these high-level programming languages like Python, JavaScript, and terminal scripts, which don't require lots of complicated programming or essentially typing. If we need to type in programming, meaning give each variable its type and then keep in control of the types of the variables, that makes programming difficult in the first hand. And these languages don't have that, so they are much easier to use. You can essentially give commands, do this and then do this, and create loops for repeating things and different kinds of programming structures anyway, but without that typing. So that makes it easier. And then when we can create these workflows through scripting, these workflows can be kept and preserved, and they can be easily modified for new purposes. Change a little bit at some point of it. And actually, when we get used to scripting, then we begin to know the scripts, and we can even read a script and know what it makes. Certainly, some of you know that already very well from your courses. So that's why this map scripting, as artistic as cartography is as a skill, and it has begun from really manual drawing of maps, and knowing like cartography certainly still would require knowing to draw maps by hand very well. But then for professional map making and for published map making, scripting is also an essential skill. Well, there is more threshold for the programming skills, of course, but then that is learnable, I would say. I would say for everyone these days. Okay, maybe this is one of the last slides of the tools. So artificial intelligence. How many use artificial intelligence every day in their schoolwork? Okay, now I should say that everyone should show hands because well, I would say that it's necessary. But then of course you need to know what you do, and you need to see what you get from the AI. And this is very difficult for the education, to my view, because even in the professional world, we see that we so easily, if we need something fast done, and then we need something to do, and we give that task to AI. And if we don't think that ourselves, then it becomes a problem later, typically. So in the education phase, certainly it's very important to think everything oneself and make it slow enough. But I think this discussion is quite active in education world as well, isn't it, Camilla? Yeah.
Talk about this a lot also. Some of you who have taken the AutoGIS courses talk about how we can use AI responsibly in our work.
Yeah, right. So in the map making world and in the geoinformatics world a little bit more generally, one of the most important application areas has been this image interpretation and feature extraction. Extracting features from the remote sensing products like aerial images directly to then input them into a map. Clustering is central. It can make spatial clusters or then semantic or taxonomic clusters, so conceptual clusters of different kinds of features to classify them together and show on a map purposefully. And this quality point is really important in with about artificial intelligence, because the data to supervise artificial intelligence, which in fact can be many forms. It can be supervised, unsupervised, or anything. And some automation is artificial intelligence too, in the wide sense, of course. So, but the data underlying must be really high quality for getting good results, also in the supervised learning. I'll show an example of this. And then we need to think about the human expertise also in all the work that is made with artificial intelligence as well. And we must understand what the artificial intelligence has done and how it has analyzed the journey from data. That is where we often fail, because AI systems, in a way, they are very complex technical and programmatic systems. But anyway, like seeing the input data and the result data is somehow in the core of understanding what works, because these are for example, neural networks that we use very much. They follow human ways of organizing information. So they essentially don't do different things that we can do as humans, but they certainly can do it much faster. And then, if applied differently, they can like create quite strange things to us. That has also been seen in many examples in cartography, when like not exactly well fit AI architectures have been applied to some tasks. So it's a complex world, but very efficient one. And then one thing that we often see also in cartography and in geoinformatics and in geospatial science is that that spatial thinking is so essential for us as human beings. So we want to understand what we have around us and how we act in that environment. So maybe we wouldn't even like to give too much of that automatized. And we need to keep our own understanding, and so to say, not to let the machine do all the work, all the thinking work, all the time. This is our application of that area about machine vision for mapping ditches and water courses at the NLS. There are also other features that have been extracted using these neural networks. In this case, mainly we have used this UNet architecture, which is very common for these machine vision tasks. And this allows to map really efficiently different features, like these ditches all around the world. Well, yeah, all around the world, but firsthand in the country, in Finland. And one interesting point of this is the high quality of data that we have, because even this one is a ditch. It cannot be necessarily seen very clearly on the photo, but for the terrain it can be seen even less while walking there. And that then creates the question of what should be put into the map. So what is the level of mapping as well? And this ditch, particular ditch, for example, wouldn't be put in the map of the National Land Survey of Finland, but it could be put on the map of some Finnish Environmental Institute, for example, or any environmental institute, to understand how the water flows, because this can still affect the flow of water in the terrain. So that's also part of cartography, to think what we map and with which tools. All right, let's continue. Uh, with Kamiar, we talked a little bit that let's change the schedule slightly so that we can do. I have these parts of the map user interfaces and then scientific research on cartography still. I'll try to go to this a little bit faster now, in about a little bit less than half an hour, and then we could make the discussion of half an hour, and take your accounts more about the topic. Does that sound okay? Okay, great. You seem to be a little bit woken up again through the pause. You were very awake. I thank you for that already. So about user interfaces of maps. This is maybe one of the main things of user interfaces and the interactivity, of course. All of us know this. Interactive multi-scale maps, pan and zoom maps, or some say call these slippy maps as well in the cartographic society. So this is certainly like the central change from the paper maps and static map images into interactive map making. And this is what also creates much of the engineering work necessary that lies behind creating these presentations. And yeah, well, that about that, not to talk too long, but there we see the main paradigm for modern cartography, or one of the main paradigms. Um, this is also something that I wanted to present you from our works at the Department of Geovisualization and Cartography, because this also applies maps, but this is like for the use of maps in a GIS system for collaborative work. So maps as well, they create us images of the surrounding world, the environment, the surrounding spaces, and that's why actually so often different kinds of decision-making systems and platforms are built on top of maps. And there happened to be a project for us about maritime spatial planning, which is a very multidisciplinary activity between different kinds of actors and stakeholders on the seas. Also on the Baltic Sea, which is a very crowded or congested one as for the traffic, and different kinds of actors are moving around the sea and using it for different kinds of purposes, from military to oil transport, to the other modes of transport, and also laser boating, and all kinds of things are happening there. Also, some usage of the sea bottom and natural resources, wind energy, and all kinds of actions. And these people need to talk together and understand they should understand each other and be able to plan together what to do on the seas to keep the seas in the good shape anyway, and also to be able to do some actions that are necessary there for the modern society, and discuss how to proceed. And this same kind of planning situations exist on the land, of course, very much, and in every city has a land use planning department, and these are central questions. So, but in the sea space, they didn't have very advanced systems for this, and particularly they lacked the digital environments for discussion. And actually, these have not been created yet very widely, because typically GIS are self-used or individually used software that people people then or the experts used, and then they give their expert views to the committees and so on. But in this case, the idea was that we want to bring that group of people working together in order to understand the situation similarly through this map platform, and there the word map and the cartography is also essential, and then to create common understanding of the situation and discuss it through and get forward with the task that they have in mind, or mainly in the planning. And this then makes the, so to say, the power of maps also very, very visible, because it's in essence the maps that then make them understand the environment also in this GIS system. So technically this was for palm size and larger displays, so that every different display in that room where these people are working together could access the same workspace, which is essentially here are many workspaces, and this is one workspace where all of these people are connected, and this imports data from different data providers through those APIs that I mentioned earlier particularly, and then maybe also some local files and such things for them to work together. Yes, we also here, as researchers, we always tend to use this free and open software to be able to modify the software freely as much as we are able to, and that's mainly about it. So this was called Baltic Explorer. This is a promotion figure for it, mainly web map application for collaborative maritime planning, as it says. I have a short video of this, but maybe I go forward not to use time too much there. Geosocial networks is one important use of map-based platforms as well. And there, for example, this kind of hyperlocal thinking has become very popular last days, to find out more things that we actually know about our very close environments, because there are so different views to the space, and that can be accessed through the maps. And then this kind of geosocial networks can also make people interact more in their close views. We had a project about this for creating such map application, web map application on smartphones. Those were like still a little bit beginning times of the map applications, times of the Foursquare and such. How many of you know Foursquare? Some, but not very many. Well, it's not very useful these days, but it was beginning times of social media. There was this Foursquare where people can log into places. So it was essentially a placial or space-based or place-based social media for people to meet and like collect some kinds of badges from visiting places and such things. But it didn't, to my observation, well, I'm not very active user of social media anyway, but to my view, it didn't grow very huge. It was very, very active in the beginning, 2014 or something, 15 maybe, but then it became less active somehow. But this had a little bit similar kind of idea of hyperlocal information shown on the maps, and then to make people approach their close surroundings better. Crowdsourcing also is one thing to mention, where also map-based platforms are really central. This is example from us. But do you know geocaching? Do you know geocaching? Many know. Yes, maybe even more than Foursquare. Okay, well that's nice, because that's a very active and open community which can make you find nice places and an interesting place. And it's also gamified, because this was also gamified approach that we made for collecting locations of border markers, which are essentially this kind, for example, this kind of rock piles from ancient times, sometimes from ancient times, in the nodes of the the land parcels, because Finland has a very efficient cadastral system that the National Land Survey maintains, which defines who owns which land, and very accurately also based on these border markers. But the location of these border markers are in many cases unknown when they are in wilderness and so on. And there was effort to collect them through this kind of game where these orange points were border markers not found yet, and people were to go and find them. And we had very keen participation during Corona times that maybe helped us with more than 4,500 users and more than 30,000 contributions during about a little bit more than 1 year. And there we succeeded to do this crowdsourcing collection, which, for example, geocaching has a very active community on, and where also I believe maps have a central point, because if we provide nice maps, then people also like to explore the surroundings on the map as well, and then go out and do these kinds of crowdsourcing tours and contribute to that map, in fact, that they see. All right. Last parts of the lecture, and well, most interesting in a way to myself, because I'm a researcher. So how then do we approach cartography as a research discipline? And because it's an engineering discipline, so it's very much about a productive discipline, so production of maps, and not that much studying very closely what the use is, but just like by the provide demand and provide logics of the commerce. But then in science, of course, we want to try and study these things still deeper and understand what people do with maps and how those are understood and how they should be made always better from the scientific point of view. And well, historically, cartography, maybe not as a science, but as a discipline, has become, since human learned to draw, probably on the sand, as I mentioned. And very long times, cartographical knowledge and understanding about how to make good maps was mainly transferred by master student education in professional map makers studios. And very rare people actually doing it, very rare able to have those days data, so the measurements from some land surveyors, but also some observations by world explorers and such people who brought the understanding. So these days the data to these cartographers. It's fascinating discipline actually historically, and I think there is still currently one exhibition in Suomenlinna about history of cartography in the Finnish case. But if you are interested in any way in maps, then those are fascinating things to ask. How were maps made before, and how could they know these things about the world anyway? But then later, when the science as such developed further, and importantly, actually, psychology emerged in the end of the 19th century. Psychology created then these forms, these theories of perceptual forms, or this Gestalt theory, and this discipline of spatial cognition emerged in those days about 100 years ago. Then also cartography began to become in a way more serious and more science based. So the scientific method of observation, measuring, and analyzing, and then hypothesizing and achieving scientific results became became also taken into account in cartography. And these cartography textbooks for cartography developed, maybe this might be one of the first where the cartographic knowledge has been really collected together in structured way by Edward Imhoff, and about cartographic representation. It's about something like that. Certainly someone of you knows better what that means in German. But then in Bertan's, quite in the same time, in Bertan's book of graphic semiology. So significance of symbols and their reading on paper in different forms. That can be also diagrams, but importantly maps, or carte is not exactly a map in French, but these like drawings of symbols, let's say. And these are still something to look at if one studies cartography. But then since 70s there was this emergence of empirical cartography, when people really began to study how maps are read and apply scientific methods from the user study of users as human studies in that sense. And then there was some kind of new way actually emerged 2010s, still continuing to some amount. Around the spatial cognition essentially, but other techniques as well that I'll tell more in a while. But the spatial cognition itself is a study of human thinking, which lies under the use of geospatial representations, so maps essentially. There are such concepts as landmarks, which are those elements in the environment through which we think about the environment: building, tree, road, even sky, or so. And then wayfinding is about finding one's way in the environment. It's very central in spatial cognition because lots of our thinking is around how to find one's way from one place to another. And then map reading from the cartographic point of view is central, on which empirical research then can be made. And for example, in a recent, well, not very recent, but something that we are still analyzing, a study about map reading of different kinds of maps, common map types, including actually aerial images in this case. So how these are read and understood, and what kind of information people are able to find from these. This has been one of my personal interests, although very difficult to study and find funding. But I made some of that in my dissertation, so that's something if you are interested in that, about in that kind of topic. And then we do these days, we have so good tools to do the analysis of how people how people read the maps. So what features have they pointed to? For example, in this case, we ask them to point landmarks that they would use for navigating this route, and we can see how these pointings distribute in different kinds of maps. So we already see some differences here between different kinds of maps. So people look at the different landmarks from different presentations. And then here we have some numbers, some distribution of the different kinds of landmarks, so passages, structures, land cover, and so on, what people have used in this study. In the history, this study of spatial cognition has developed from those years I explained about 100 years ago. And well, psychology began as this kind of armchair experiment. These researchers just thinking how people think, essentially in their chairs. Trowbridge being one of the earliest who mentioned these imaginary maps. They made an observation that was very common in psychology, that people have many failures in their thinking. That was somehow how the psychology began, as I have understood. So why people think so falsely? If you begin to analyze, you see that people think very wrong all the time, actually. So we have like interpretation of the reality that cannot be like critically really looked through, and that is also very true for the surroundings and the maps. And then they began to wonder how to study this, and can we somehow then as human beings also be more understanding about our environments. And then there were these experiments on animals, which were common in the beginning of the psychology, where they tended also to do some generalizations between animals and humans. And actually, well, these days they have found that there are similar neural, so brain structures, so those were not so wrong. But one of the central ones was rats walking in these kinds of mazes and searching for food. And these studies showed that the rats were able to find their way and make shortcuts even in these mazes, which showed that they were able to create this spatial understanding. So it was found that this spatial understanding exists in human brain in this sense. And then Edward Tolman made this, but then also essentially created the basis for this model of spatial knowledge that was then collected together by this Siegel and White 1975, and where they made this theory of landmark, route, and configuration knowledge, according to which it can be said that we organize the knowledge of the environment in our heads. And that still holds to some amount. There have been lots of discussion if how true is that, but it still accounts quite well, and it's also practically it has been practically useful to create, for example, maps and map applications with these ideas. So landmarks being those objects, routes being connected views of these between these landmarks in a sequence. And then configuration knowledge being the one that actually allows for these shortcuts for the rats, for example, so that we can understand putting these objects in some coordinate system, we could say in geographic terms. So we know where these different things will be in the environment and how we can then navigate among them, for example. And this configuration knowledge is actually something that we then want to create with maps straight on, so that we don't need to wander around and find out about the environment ourselves, but we can understand it through maps right away. And then it has gone to neuroimaging in this psychological sense since then, and there was even this spatial neuron that was found in 2000. They made this research very long times, but they received Nobel Prize 2014 about finding this kind of cell in the brain that particularly processes these spatial relations and spatial thinking. I'm not a brain scientist myself, but these studies are still made to understand further the spatial thinking. This is the knowledge acquisition that I already told. So about this landmark, route, and configurational knowledge, I mainly said this. So going forward, and well, I myself in my doctoral work I made this kind of classification of these different kinds of geopictures, as I called them, which depict reality differently and show different forms of the world, and then for that reason create different kinds of understandings in this sense of landmark route and configuration knowledge. But then I still wanted to say a couple of words about this empirical cartography, and now this also relates to the study of Anna Sarnen for her diploma thesis that many of you have probably participated, and if not, please, you can still participate. It's an, I would say, an interesting study, and supports her in her graduation, of course. But empirical cartography is then comparing how different kinds of visualizations are doing in the very like graphical and basic sense, like this, where these are not real maps. It's just studying how these different forms are seen on these maps, but then also in realistic cases, like with world maps in here and with some connected lines, and how these can be supported with multi-line presentations, for example, about such things as where a helicopter pilot could land most easily, and this were expert professional helicopter pilots. They wanted to study in Switzerland which of these, in quite early days of these presentations, which of these could be most efficient. And they found that this slope representation would be most efficient, which directly shows the inclination of the terrain, and then tells the helicopter pilot a good place to land or not. These hill shadings are nice to show the forms of the hills, but the direct representation of the slope was the most efficient that day. Then this eye tracking camera, that is also what we are using and what Anna is doing currently with her study. It's essentially a device measuring how our eyes move, so how our pupil moves, with some infrared cameras in it, and measuring the location of the gaze on the screen with X and Y screen coordinates, and then the time stamp for each measurement. In our case, 250 times per second, as it's a 250 Hertz device. And then through these, it's possible to define fixations, which are essentially points of the stopping of the gaze, where we are able to receive information in our brain. Because then there are also these saccades, which are these movements between these fixations, and based on the current understanding, it's not possible for us to process that information in our brain. Maybe very unconsciously there is something happening, and that's what they are currently studying in the study of the visual system of human being. But essentially, we need to understand what happens in the fixations. Maybe something through the pupil can be studied as well. Eye tracking data as raw data looks like this. And then this is actually an example of why we do eye tracking research. Because and what is essential in eye tracking research, because if you look at this figure, you might see something else that you see in the very beginning when you see this figure. Can you find anything a little bit hidden in that figure? I don't know if you have seen this before, but do you find something in there? Faces, isn't it? And quite many of them. And that actually shows that when you see that form of a face, which is very common, or which is very known for a human being, of course, we always want to understand faces of other people. So then we are used to process them. And then in the beginning we don't see them, but when we see one, for example here, then we understand, okay, we have these kinds of forms in this figure, and then we begin to see more and more of them. a little bit everywhere, as they are hidden in this figure. There are very many of them. I don't remember the exact number, but maybe 12 of them at least, or over. So these kinds of processes of understanding can be studied also with eye tracking. Maybe one example only of these eye tracking studies, so that we can get to the discussion. But this was one by Sarah Fabrikant and group from University of Zurich, where they studied how this kind of professional air pressure maps of meteorologists can be read and understood by the meteorologists based on their when varying the visualization with colors, essentially. So the other has colors, the other doesn't. And we see that the one without the colors becomes like less fixation points and less saccage and less wandering around the figure. Very widely said. There is much more to it that must be studied when doing it scientifically, but generally said like that. And these kinds of findings can then tell us about the superiority of one map to another in some sense. But then, of course, all these studies require a very careful setup and understanding what is being studied and so on. You will see one example if you go to the study of. There are many of these, and